So welcome to the video lecture series on Introduction to Computer Networks. This is part 3 of our lecture series on the topic of wireless LANs. So let us jump to the point where we left off. All right. So when we are talking about wireless LANs, there are certain elements which are related to the operational specification of wireless LANs. So a wireless LAN architecture architecture can be operating in two modes that we have already seen. One is the infrastructure mode, where we have a centralized access point to facilitate connections, and in the other case we have the ad hoc mode, which is without an infrastructure, which does not have a centralized element for connection. So in the infrastructure mode, we have an access point which allows the nodes to connect to the network. And if you see the way that the network is organized, is that we have these small cells which are provided by individual or separate access points, and each of these access points are connected to a wired network. And then, for example, if you consider a campus wireless network, there are multiple wireless routers placed across different rooms, different hallways, corridors, and also different parts of the outdoor areas in a campus. But however, if you have noticed that once you connect to the university wireless network, even if you are moving from one building to another, you are still connected to the same network. So that is something that we can see as well, that if we have multiple access points providing the network for different small locations or regions, they still fall under a larger same network. So we will look at the different terminologies which are required for all of these cases. So first we have access points, which are the base stations in the infrastructure mode, and then we have something called the SSID. In full format is the service set identifier, and this is the name that is advertised by the access point. So this is basically the network name that you connect whenever you want to be connected to the wireless network. Something that you don't really see as a user is the BSSID, which is the basic service set identifier, and this is a 48-bit label for the access point. This is kind of similar but not exactly the same, but similar to MAC address for routers. But in this case, this is an identifier which is 48-bit long, and this applies to each of the access points which are there in the network. So you don't really see it as a user, but it is a part of the configuration which is incorporated into the routers. And then, so if you have multiple access points operating together as one single very large network, for that we have what we call the ESSID. That is the extended service set identifier, and multiple APs with multiple BSSIDs, because we know that BSSIDs are unique. So when multiple APs with multiple BSSIDs are connected to the same or required to be a part of the same wireless network, they need to have the same SSID. And all of this together actually is referred to as the extended service set identifier. And for example, if you're connected to the network, the wireless network of the campus, you connect to the ESSID of the campus. And the other thing is that you would also require the feature of handoff, which means, for example, you are walking out from one building of the campus into another building. Your mobile device is required to be shifted from the connection of one access point which is in the first building, to another access point in the second building. So this particular feature is what we call as handoff. And finally, we have something called the WDS, or the wireless distribution system. And this is the backbone system which allows all of these multiple APs to be working with each other, providing the handoff, providing the single network connectivity, so that you are a part of a very large wireless network. Alternatively, if you are looking at the no infrastructure mode, that is the ad hoc mode of wireless networks, we don't really have the SSID or the ESSIDs anymore. Instead, we have an IBSS, that is the independent basic service set. And this is used for wireless networks without a centralized access point, and they generally work in ad hoc mode, which is like a peer-to-peer mode, and they're very useful for quick and easy setup. What it generally does is that the first laptop would basically create an IBSS and set up the ad hoc wireless network, and then it has a certain range within which any other node which is present can connect to it. So whenever this is connected, the range gets extended for the IBSS, and then another node can also participate or get included in that ad hoc network. So in the case of ad hoc networks, the network is identified using IBSS. For infrastructure mode wireless networks, they are identified in the simplest form using SSIDs for individual access points, or ESSIDs when multiple access points are working together to form a larger wireless network. The management of the ESSID is done through the wireless distribution system, or the WDS, which allows this multiple access points to operate together and also create allow the flexibility of the users to roam around, and also to allow the handoff from one access point to another. And each access point individually can be identified using the BSSID, which is a unique 48-bit label for an access point, kind of similar to a MAC address. So when a wireless node needs to connect to a wireless access point, or needs to connect to another wireless device, both of them needs to have a commonly agreed wireless frequency that they would be communicating over. This particular frequency is referred to as the wireless channel. That is the commonly agreed frequency between two endpoints. So if we look at the different standards, they have the range between which the wireless nodes can choose a channel. For example, the 802.11b, which is a specific version of WLAN, it operates between 2.4 and 2.485 gigahertz. So this whole range is divided into 11 independent channels. So each channel has a unique frequency within the allowed range. So what happens is that during the time of configuration, the access point is assigned a specific frequency. And that is going to be the frequency for that particular cell, and all other wireless nodes which needs to connect to that particular access point needs to operate in the chosen or specified frequency. There may be signal interference because if in case the chosen frequency is overlapping with any other nearby device, and in that case you get a degraded performance of your wireless network. And before the wireless host connects to the access point, it needs to go through a process called channel association. And what happens during this process is that the wireless node needs to scan the channels. In the case of 802.11b, there are 11 channels. So it needs to scan all of these channels, listening to what we call beacon frames. And the beacon frames are more like advertisement frames. So they are frames which a wireless node can receive and learn about the access point. It will describe the SSID, the MAC address, the channel, and all the other required information in the beacon frame. And when the host receives one of these beacon frames, it can then select an access point. So once it selects an access point, after that it gets associated with that frequency. Optionally, it may require authentication, which we see as a common practice now, but that is not a part of the data link layer. It's something which is more of an application that is enforced on the end nodes which are connecting. And after that, once the frequency is associated and optionally authenticated, it needs to get an IP address assigned from the access point. And again, in most common setups, we see that the access point is actually assigned through what we call the DHCP server. The DHCP is a domain host control protocol server, and this is responsible for assigning IP addresses to all devices which are connected to a network. So if we look at how the association works, there are two ways in which a node can go through the process of channel association. First, we call it as passive scanning. So in this case, let's consider two access points, AP1 and AP2. AP1 and AP2 are both transmitting beacon frames within their cell, that is their coverage area. So whenever a host, in this case host 1, enters a region in which it can receive those beacon frames, it can then decide which access point it will associate with. So in this example, host 1 enters a region where it can receive the beacon frames from both AP1 and AP2. These beacon frames are called association request. These beacon frames are sent out from APs, and once the host selects the specific access point, it then sends out an association request to the selected access point. So this is a frame which is sent from H1 to the selected access point on the chosen frequency, asking itself to be associated with that access point. If the association is successful, the access point will then respond with what we call an association response. So when the host receives the association response from the selected access point, it will know that it can now start transmitting and receiving over the chosen frequency with the chosen access point. The second kind of channel association can be facilitated through what we call as active scanning. So in this case, unlike the previous one, it is the host which actually requests or asks all the available access points to send their advertisement to the host. So in this example, host 1 enters a region where it's actually able to reach both access 1 and access 2. So host 1 would send what we call a probe request frame, and this is broadcasted across all the available frequencies. So given that it is broadcasters in all the available frequencies, all access points which are operating within reach will be able to receive one of the probe requests that is being sent out from H1. So once the access points receive the probe request, they respond with a probe response frame. So this is actually sent from all access points which receive a probe request, and all of them decide on sending a probe response to the host. Once the host receives all of these probe responses, it goes through the process of selection and choosing probably the more stronger signal, and then it sends out an association request to the selected access point. When the access point receives the association request, this needs to be sent over the chosen frequency, and then if everything goes all right, it will respond to the host with what we call the association response frame. So once the host receives the association response from the access point, it is now confirmed that it is able to from now on send and receive data over the link and in that chosen frequency, and then it can start transmitting.